Hi, I'm Sami Kuba.
And I'm Kelly Akins, Program Manager for Incident Readiness.
And I run the Azure Communications team. Our team communicates to customers during impacting events. This could be a maintenance, a retirement of a feature or a service, or in worst cases, an impacting incident. Now, these incidents are inevitable, but impact to customers doesn't have to be. These sessions will walk customers through parts of our well-architected framework, whether it's taking advantage of the resiliency options that Azure makes available to customers, or the best practices for your application once they've migrated from on-prem into the cloud, or even troubleshooting your environment.
That's right. So we're here to translate those readiness recommendations into practical, actionable solutions to help you prepare for the unexpected, with our ultimate goal of helping you minimize or even prevent the impact of incidents. So we hope you enjoy the conversation. Thank you. And welcome everyone to our third incident readiness session. Sami, do you want to just kick us off with what we have in store?
Super. We have Brian who's going to be talking about an insight in our communications approach. Now, a lot of people, they'll use our status page or they're somewhat familiar with service health, but we have Brian here to talk about when we communicate via one path over another. In previous sessions, we have talked about customers setting up a service health alert, which is wonderful when you're talking about a subscription singular. But if you have multiple subscriptions, if you have an environment that's constantly onboarding subscriptions and you want to ensure that that you keep up to date with this kind of dynamic changing situation, then we have Paul and Arjun to talk about this. So yeah, they'll be talking about the service health alerts. Kelly, what else do we have going on?
Thanks so much. So after we have notifications and getting informed and staying informed, we'll switch to a topic that was requested in a previous session, and that's threat actor hunting. So with cyber threat actors upping their game, understanding their tactics is key to protecting our systems. Luckily, Emily will guide us through a live demo simulating a cyber incident response, showing us how to spot and track these threat actors. After Emily's successful hunt, we'll pivot to our resiliency story, focusing on Azure ExpressRoute. If you're interested, if you use it, or if you plan on using Azure ExpressRoute, don't go anywhere because Shruti will guide us through our resiliency options to make sure that your Azure connection to on-prem is both highly available and resilient to meet your business needs. So now that we've set the stage, just want to remind everybody again, we do have Q&A open, as Sami mentioned. So we have a bunch of experts waiting, standing by to answer any questions you may have. So let's put them to work. And now I'm thrilled to pass it over to Brian, who's going to cover Azure Communications. Brian?
Thanks, Kelly. Thanks, Sami. Hi, everyone. I'm Brian Slater, Program Manager on the Azure Communications team. Today, I wanted to talk a little bit about comms and what type of events that we communicate on Azure and the mediums that we use and why we use those mediums. As for the types that we communicate, which you see on screen here, we do have service issues, which are outages, and those are unplanned events affecting your resources. We have our planned maintenance notifications, which are typically proactive notice of activities of maintenance type occurring across the platform. Health advisories, which include a variety of different event types, such as informational, which are awareness notifications for enhancements that were being made to services, as well as action required notifications, which are potential issues we've identified with your resources. And these notifications include guidance to help you remedy those issues we found. We also have retirement awareness notifications, which are upcoming breaking changes or deprecations of features, functionality, or other services. And then we also have security advisories, which are issues that are related to vulnerabilities, breaches, or threats occurring across the platform. As for the mediums that we communicate under, we have our Service Health Blade within the Azure portal. We leverage Service Health for a variety of these events and is the vast majority of our notifications, as you can see there. Service Health provides you a tailored experience where we provide affected service and resource details for these events and guidance that can help you take action and make important business decisions when you receive these notifications. Additionally, which we'll dive into a lot more further later, is our alerting functionality built into Service Health that you can take advantage of to keep your company and your organization informed as needed through various channels like SMS, email, or even webhook, which you can leverage to integrate with monitoring solutions and incident management tools that you use to streamline response processes and improve incident tracking, as well as pushing these notifications to your customers to keep them directly informed. As far as the status page, we do leverage this as a backup medium for widespread outages or when we're unable to effectively keep our customers informed through targeted methods, such as when the portal is unavailable. However, the communications that we provide here are generally high-level details, as again, Service Health provides that more tailored experience, but the status page allows us for when we require for these broad impacting issues to at least keep you informed at a high level. We also do take advantage of our Twitter page, the @Azure support handle, which is typically for individual support response medium that we use. But we do leverage it for amplifying our major outages, pointing you to Service Health or the status page to stay informed during those widespread issues. So again, it's of the utmost importance that our customers are prepared, knowing how Service Health works, and most critically, that you do configure your Service Health alerts so you can stay informed in a timely notice or with timely notice. So to dive further into this, I'm going to hand this over to Paul Grimley, who's going to talk about a scalable solution using Azure Monitor baseline alerts to configure and maintain your Service Health alerts as your company evolves. Over to you, Paul.
Thank you, Brian. Hi, everyone. I'm Paul Grimley, Principal Technical Program Manager working on AMBA Service Health Alerts. I'm going to spend a couple of minutes introducing AMBA before handing over to Ian, who will walk you through a demo. AMBA was released in October 2023. It was initially built as part of Azure Landing Zones, and you may hear mentioned the Azure Landing Zone pattern, which focuses predominantly on platform alerts such as Service Health. For those that aren't aware of AMBA, AMBA is a one-stop shop for Azure services, monitoring and alerting guidance, covering 500 plus metrics and alerts across 67 Azure services today and expanding. In today's demo, we'll focus on one of the AMBA capabilities, Service Health Alerts. But first, let's talk about the scenario of why we need to scale Service Health Alerts and how AMBA can help. So currently, today, in the Service Health portal, the dashboard, you can only configure alerts at subscription level. Customers have been asking for the ability to scale that above a subscription. Many customers are using AMBA to achieve that. And where we've got customers with tens, hundreds, or even thousands of subscriptions, AMBA is an easy way to allow that compliance across your entire estate. As I say, the benefits, some of the key benefits of AMBA are that ability to rise above a subscription and allow that compliance across multiple subscriptions at ease. And they're used as Azure policies are used as a mechanism to do so. So on the next slide, I'm going to talk to you a little bit about the management group and how we align to that and how you can address this at scale. So from the diagram we've got here, this is a typical management group structure based on Azure Landing Zones. In the top right-hand corner of the diagram, we have the Alerting Service Health Initiative. This bundles all the different types of alerts that Ian will talk about shortly before diving into the demo. So if you look in the middle of the diagram, you'll see a Contoso targeted assignment of that initiative. What this effectively means is it allows you to target every subscription that is under your intermediate root group that falls under there and inherits automatically. One final thing before I pass over to Ian to mention is that you can target these alerts through flexibility. So you can toggle if you want to have subscriptions turned on or off to be able to achieve these. And Ian will go more into that as we transition to the next slide. Over to you, Ian.
Thank you, Paul. I'm Arjen, Cloud Solution Architect. And let's take a bit of time to explore how these alerts work and how we can implement them. As Paul mentioned, we assign an initiative, an Azure policy initiative at a management group level. Now, you're very flexible and decide where you want to place that. It's usually at the intermediate route management group, but you can see and how that fits into your environment. Now, this initiative consists of multiple policies. We have policy that will help you set up alerts for resource health or for service issues, or maybe even plant maintenance. You can pick and choose which instance and which policies you would like to implement, and then you can tailor that to your environment. Now, we'll take a look at a bit more detail on how they work. We'll dive into how such a policy works and when it implements and when you target certain resources, because these policies effectively are deploy if not exist. But it basically means that you will target the policy to a certain type of resource and will verify whether a certain configuration is present. If it's not present, it will implement it for you. And one of the things that we do aside from these policies, which is optional, but you can pick and choose, is deploy an action group. If you already have one in place, perfectly, that's the one that you can use. If not, you can use one of the action groups that we deploy. And that action group will allow you to configure certain actions or notifications. So if we take a look at the next slide here, we'll show you that aside from typical email notifications, you can also pick using logic apps, or maybe you want to send an email to ARM roles that you already have configured on your subscription. Or maybe even something like a webhook, send a notification to your ITSM system. So you have that wide flexibility there. You can really tailor it to your needs. So when we take a look at the demo in a moment, we will also see, what happens, what's deployed. So let's take a look here. Like we'll go dive a bit deeper into that deploy if not exist policy. We'll look at the statement that really allows you to say we're targeting that resource. We'll look at the existence condition in the policy, and we'll explain what that's for in a moment. We'll configure the parameter file, and we'll run through a deployment. And then in the end, we'll take a look at everything that is actually deployed. So I'll take a moment and share my screen, and we'll start off here with a view of my Visual Studio Code, right? This is a template that we can deploy through the command line. And I know it looks maybe a bit complicated, but we have deployment guidance, and we'll make sure that we leave a link to that deployment guidance here in the chat so you can look through it and follow along. But it's actually not that complicated, right? Everything is pre-built, all the templates are there, and it's, like you will see in a moment, only a few commands that you have to run. Well, let's dive a bit deeper into how a policy look like, right? I have one open here, and I'll scroll down a moment. We can have some parameters here, but let's scroll down a moment to what we see here in the policy rule. And the policy rule really is that part of the deploy if not exist that says, you know what, if you have a subscription, that's really the resource that we're targeting. Now, if you pay attention here at the bottom, we have another condition there that looks for a monitor disable. So you can actually exclude certain subscriptions from this monitoring. So you say, maybe I have development subscriptions, or I have some sandbox subscriptions that I don't want to monitor. That's perfectly fine. You can tag them, like in this example with the monitor disabled, you set it to true, and it will not target that subscription in particular. Now, it finds the subscriptions, but you also have subscriptions that maybe already have a certain configuration, and that's really where the existence conditions come in, right? So that basically will allow you to target subscriptions that don't have it yet, and if it already has the alerts configured, then this existence conditions will make sure that you're not deploying it again. Also, maybe sometimes a subscription may be out of compliance. Maybe someone deleted an alert or changed something. This will help you track that and make sure that those subscriptions stay compliant. Now, deploy if not exist for new subscriptions will automatically make the necessary configurations. So maybe you create new subscriptions, you will get the alerts automatically. For an existing environment, it will mark it as non-compliant initially. No problem, we do provide a script that will help you set up those alerts at scale. Let's say you have 3,000 subscriptions already. As soon as you deploy this, it will mark them as non-compliant. You run the script, and it will remediate all of those subscriptions for you with very little effort. Now, all of the things that you can set with these policies, the moment of deployment, we do have a parameter file that you can configure. So you can make sure to tweak maybe the resource group name, or maybe you want to enable or disable some alerts, or simply point it to the right management group structure. So we really start off with that part, right? So you can select the management group structure initially with the intermediate route that Paul was showing on that image earlier. And you can place it, like I said, to the management group structure that you have in your environment. Now, scrolling down a bit further, you have some options here to enable or disable some of the capabilities. In this case, since we're really focusing on service health, I've enabled service health for this deployment, but you could also pick one of the other options that we have here, enable, disable, depending on your requirements. Now, you have the policy, the possibility here to change the resource group name, and you can see it's a very extensive file where you can basically make all of the modifications that you would really need to. Most of the defaults are already properly set, but definitely this part that we're looking at now will need some of your information. And do you want to use a webhook? Do you point to a logic app? Maybe just an email address, right? It's all up to you. So let's take a moment now and look at how a deployment looks like, right? I'll just use some commands here and only have to say where I want to deploy it. So I'm looking to deploy it to North Europe, and I will say that my intermediate route management group, also sometimes called pseudo route management group, is called Contoso. So I'll make sure that my environment is set up with those configurations, and then it's only one command line that points towards the ARM template. We'll run that as well. And in this case, we don't have to wait for it to finish. We'll switch over to my other screen where I have the environment set up, and we can take a look at how that looks like when we have deployed it. So here we are in the Azure portal. You'll see that I have the initiative assigned, and we're now looking at the compliance of that. Now, this is already have been remediated. You'll see that all of my 4 subscriptions are indeed compliant and have those resources created. Now, if you have existing subscriptions and you deploy this, you will initially see this as non-compliant, but as I mentioned earlier, you can use that script to automatically remediate all of your subscriptions. Let's take a moment and go into the resources that it actually deployed. So let's open one of the resource groups. So I left it as the default, which is just AMBA monitoring 001. But as I said, you can change the name if you would like to do so. Looking at the details here, we see that it created some of the activity log alert rules for service health, advisories, incident, etc. You also see the action group here on top. I clicked on something that I shouldn't have. Here we are back. You also see the action group here on top, right? So let's go into that action group and actually fire up one of those emails. Let's say we have an email configured and you just want to make sure that everything works. So inside the action group, you can actually select test there. As soon as you select test, another window opens to the side, and whatever you have set up, in my case, it's an email address, you can do a test to make sure everything is working correctly. Now, you have multiple different test solutions, test emails or test notifications that you can configure. One of them is actually the service health alerts. So you can set up a service health alert this way, then the action group, and you can run a test, and then you can really follow that entire process to make sure everything works for you. In this case, I'll have an email address, I'll select test, and it will run through that test deployment. Now, let's go back to one of the emails that I sent earlier. This is just that email, right? It will tell you information about what it found. So in this case, impacted services were virtual machines in US West and US East. And depending on what may happen in that moment, you will see some different details. But this is one of the examples of an email that you could receive after there have been detected a service health issue. Well, thank you very much. Let's go back to our host and let's look at else what we have in store for you today.
Thank you very much. Thank you. Brian, thank you very much for providing clarity around when we use our status page versus service health, and Ian as well. Thank you very much for showing us this. I really like the print test page feature. I think it's such a good idea after we create an alert or an action group that we can kind of just run it through the system and see how that works. Previously, I've been trying to use ARM or PowerShell when I've been trying to deploy things at scale, but I'll give AMBA a go now, and I'll try out the tips from your demo. Kelly, before we go over to you very quickly, just a reminder to our customers, there are our live group moderators who are there. So if you do click on the chat icons, everyone's kind of waiting. Let's put them to work and make sure that they have a lot of stuff to do, a lot of questions to answer. But Kelly, what do we have coming up next?
Yeah, thanks, Sammy, and thanks, guys. That was a great segment. So as mentioned before, as previously requested, we have threat actor hunting coming up. So Emily, let's go hunting.
Thank you very much. Hello, everybody, and welcome to The Hunt. My name is Emily, and I am a security researcher at Microsoft, which means that my day job is often spent hunting threat actors in our cloud services. And on that note, we have a bit of a situation on our hands right now. Let's work on this one together. We've been given a brief that a user has been locked out of their own account. In addition, we have an unusually high spend occurring in Azure. Together, let's dig into what might have happened here and whether these events might be linked. Now, these types of events can often lead to downtime, disruption, and are often also financially impacting. So time is really critical for us. But with any cybersecurity investigation, setting the expectations and our investigative goals are crucial to make sure that we are making the most of the time that we have. Our goal here is to answer 3 key investigative questions. The first, has a threat actor actually gained access to our systems? And if so, how have they done that? Second, can we identify any threat actor persistence methods in the environment? And then thirdly, is there a link between our suspicious user sign-in events and our Azure spend and resource issues? So in order to do this, we're going to focus on 3 key data sources: the Entra ID sign-in activity, the Entra audit activity, and the Azure activity. Let's have a look at this data flow in some more detail. Cybersecurity investigations really hinge on the availability of good data. Without that data, we're unable to build a timeline and to tell the story of exactly what happened. Knowing where the data is and how to access it is really the first step of any good investigation. Now, in terms of Azure investigations, we have 3 main areas of interest here, as we just stated: the identity logs, or the identity plane, as we often call it, the management plane, and the data plane. Now, the identity plane consists of the sign-in logs themselves, so the actual login events, and then the audit logs, the activity relating to the identity, things like MFA methods being added, users being added to groups, things like that. This is where we're going to begin our hunt today. Second up would be the management logs. And this is telling us what happened in the Azure platform itself. This would include things like changes of permissions, the creation, modification, and possibly the destruction of resources. Let's hope not. And then lastly, we have the data plane. And this is where we can investigate what has actually happened inside of the resources. This one we're going to save for another day. Now, only a few of these data flows are enabled out of the box, as you can see from the graphic on the screen. But with some additional configuration, we can make this data flow in other directions too. This can help us increase our log retention times, keeping important critical data for longer, and allowing us to keep all of our data in one place, as you can see by the log analytics flow. Having a SIEM, a security incident and event management system, with all of the log sources integrated can really pay dividends in an investigation like this. With that said, though, for this hunt, we're going to stick with those default log locations so you can see what the raw data looks like. Okay, now we know what data we're working with. Let's talk about methodology. During this hunt, we're going to be following the tried and tested methodology used by our incident responders in many complex cybersecurity cases. It's very easy in any investigation, I've done this before, to get drowned in data, especially in today's data-rich world. So for this reason, we start with a baseline, and the identity platform is our baseline. We can figure out which identities were compromised based on the sign-in data. And once we understand this, we're likely to have a few things we can work with. We'll have some usernames that are potentially compromised, and we'll have some indicators of compromise as well. Things like IP addresses, user agent strings. Yeah, there's many different IOCs that we could gather. What we can do is we can take those and follow that data to the applications that the threat actor signed into. And we can review the logs inside those applications. What this will do is then give us the ability to collect new IOCs to build up our investigative data, and then return back to the identity data with this information and start the whole process again. It's a cyclical process. So now we've set the scene, let's actually get into it. Let's use this data and these techniques to find out what happened in this particular case. Okay, we're going to start by checking out the user page for the identity that has been reported as inaccessible by the user. Before we look at any of the logs themselves, we're going to get the lay of the land and see what kind of roles are assigned to the account and what groups the account is in. So we can see some interesting looking groups here that the account is a member of. And if we have a look at the roles, we can see that the user is a member of the global administrator role. This is a highly privileged account. Unfortunately, that means this investigation has just got a bit more serious. The account is currently in a disabled state, so the user can't log in. So let's take a look at the audit logs and see exactly what's happened. Now we can see there was quite a lot of activity happening on the 19th of April here. And if we scroll to the bottom of the timeline, see the first activity, we can see this reset password by admin event happening. We also see another event here, which is an admin deleting the security information. So these are definitely activities of interest. And followed, this is at 12:50 and 12:51, followed just a few minutes later, we actually see the user registering security information, 12:59 UTC. So we have an administrator, potentially help desk, resetting credentials and MFA methods, and then a user re-registering those. Now this could just be a user account who was locked out, but there has been a significant rise recently in social engineering attacks by ransomware and advanced persistent threat actors over the last year. Now, in particular, we have seen manipulation of help desks for the purposes of gaining initial access to accounts. And this does usually take exactly this form. So it might be worth talking to the help desk in this case, just to find out more about how this was initiated. But what's really concerning me is this activity we're seeing after the registering of security information and the resetting of the password. And that isn't a user being added to the directory. This is a guest account that we can see added here. And if we scroll up a bit further, we also see that it was added to a role. Let's have a look at this data point in particular. So if we click on the targets area here, we can see this account has been, it's a proton.me account, which is an email service that provides a high level of anonymity and is often used by threat actors. And we also see here that it's been given the global administrator role. So we have a guest account being added and given a high privileged admin role. This kind of activity would give a threat actor persistent access through a separate account as like a backup option in case the first account is discovered. Another common tactic for threat actors during all kinds of different system intrusions. So we have a series of suspicious events here. Our guest account creation, the reset of the credentials, and the user who was claiming that they were unable to access their account. So let's pivot to the sign-in logs to learn a little bit more. Okay, we've moved over to the sign-in logs now, and we have this already filtered on the date range of interest from the beginning of that password reset. And if we scroll down to the first events here, we're going to see these are very shortly after that password reset event. And we do start to see something quite unusual here. What we see is new activity to administrative interfaces like the Azure portal, AD Ibiza UX, which is actually Azure Active Directory PowerShell. And many other Microsoft Graph, we also have here many other admin interfaces, and all from different locations. We can see multiple country codes in here, multiple different IP addresses as well. Now, this user is an admin user, so them accessing the admin interfaces is not necessarily a surprise or suspicious in itself, but this pattern of activity is anomalous and looks like a threat actor using an anonymous proxy, maybe something like Tor or a VPN provider. I think we can say with relative confidence at this point that we are dealing with a compromised account here. So let's continue following the thread. We can actually close the loop on the identity activity, the identity portion of the investigation, by having a look at the authentication methods. Now, we know from the sign-in logs, or from the audit logs, I should say, that an authentication method, an MFA method, was added by the threat actor, the potential threat actor. And here we see that authentication method. We only see one authentication method here, the one that was added during that suspicious activity time frame, and it is the type software auth token. Now, not all MFA methods are made the same. We have SMS as a MFA method. We have the software auth token. And then we have the Microsoft Authenticator app with passwordless. These are all on different ends of the scale. And it's true to say that this is an uncommon type of MFA method. Users are more likely to pick an SMS text message or the Authenticator app. The reason that we often see threat actors use this particular type of MFA is because it's forensically quiet. It doesn't leave much in the way of data. It doesn't leave a phone number. And it doesn't leave anything like the make or model of the device that was added. This is all we get to see. So this is further increasing our confidence that we have malicious activity on our hands. Okay, looking at the sign-in data, told us that after the Entra ID access and those persistence methods were set up, the threat actor moved over and focused very specifically on the Azure portal. So let's go take a look at the activity that occurred during these sessions. And to do that, we're going to move over to the Azure monitor log. So our first stop here, and the closest link to the previous activity that we observed, is the directory activity area of Azure Monitor. We have two filters here, activity and directory activity. And if we look in this area, and again, we filtered the time range, we see an event at the time window of those sign-ins, April 19th, 1710 GMT +1, so 1610 UTC. And it is assigning the caller to user access admin role. What does that mean? Let's have a look at the data point. Now, in order to look at this, we're going to have to dig into some JSON. But we get the information we need right at the top here. We see the action completed was that of elevate access. This is very interesting in itself. This is an activity in Microsoft Entra ID portal. And it allows a global administrator to give themselves access to every subscription that belongs to that tenant. This is usually reserved for emergency access situations where you need to get into things as like a break glass approach. But we often see threat actors using this to move laterally from the identity plane to the management plane. And now we can see that the threat actor has done exactly that. We're going to need to look now at what activity exactly has been performed against the Azure subscriptions. So let's move over to the activity log proper. Perfect. Okay, now we are in the activity log, and this is where we're going to see resource changes and events. Again, we'll scroll down to the bottom to get to the start of the timeline, and we see some activity just after those permissions were added. First thing we see here is the update resource group activity from the same compromised Parker E account. If we look at this activity, and again, look at the JSON, We're going to have to scroll a little bit more to find what we need. But if we scroll down, we are going to find that there was a change to the resource groups. There was a write operation that was completed here to the resource groups. And the name of the resource group that was modified is dev. This is quite interesting because there is no dev resource group that we're aware of in this subscription. We have a production environment, a test environment. We do not have a dev environment. So what we'll do in a moment is go and look at this resource group in more detail and take a look at exactly what's happened in there. But first, let's have a look at what other events happened during that time frame. Now we can actually see just after this resource group was updated that we have some validate deployment events here. So this tells us that a deployment of some kind was pushed against the dev resource group, as we can see. And following that, we have various different resources being created, the most interesting one being a virtual machine scale set. This is particularly telling as well because threat actors will often set up virtual machines in victim environments for the purposes of crypto mining. They can spin up VMs, log into them, set up crypto miners. They don't have to pay for the machines, but they get the Bitcoin at the other end of it. So what we can do is we can close the loop and have a look over at the dev resource group itself. And here we see that virtual machine scale set, a load balancer, public IP address, and the virtual network that's supporting it. To get more information about the deployment that was made, we can go into deployments. And we see there are two attempted deployments here. We have a failed one at 1826 and a successful one at 1840. And if we have a look at the successful deployment, we can take a look at the inputs. And we can see a little bit more information about what was provided. It's running Server 2022 Data Center Edition of Windows. The username provided was BMSS admin. And we cannot see the password that was provided, which means that we won't be able to log into these machines and forensically analyze them. We're going to have to take a copy of the disk and look into it that way instead. So we found a lot of different information here. It's all the time that we have for a hunt today, but what we have right now is enough information to build an initial timeline. This is something we do for all of our cybersecurity investigations. So let's just take a look at the timeline itself. Now we can see initial access occurred at 12:50 UTC on the 19th of April, likely using social engineering of the help desk staff to perform a password reset and MFA reset. Very soon after this, persistence methods are added, with a new guest account being added with a high level of privilege. This follows with privilege escalation using the elevate access option to move laterally into the management plane. Then lastly, we have the impactful event, the creation of the Azure virtual machine scale sets. More investigations needed, but this is very likely being used for the purposes of crypto mining. So the last piece of information I would like to impart to you all is around the response process itself. There's many things we can all do to improve our security posture, but all too often in our industry, we focus too much on protection and not enough on detection and response. Having the correct logging, understanding the detection logic that we can use to find these types of events, reducing alert fatigue, and understanding exactly what's required and who to engage in a response scenario is vital to making sure that when a breach occurs, we can take corrective action quickly and decisively. So if you're in doubt about any of these things or have a security incident that you need help with, please don't hesitate to contact Microsoft Incident Response. And have a look at our partner blog to this hunt, which is launching today on Microsoft's Tech Community blog. And with that, I'd like to say thank you very much for joining me for the hunt and pass back to our wonderful hosts.
Super. Thank you very much, Emily, indeed. Thank you on behalf of our customers. Thank you as well for keeping us safe and teaching us to be a pseudo detective in the environment. I really like the idea that detection is one piece as well, but putting in MFA and other proactive measures can kind of solidify that. In January, we had an ExpressRoute issue, and the ExpressRoute issue was interesting because it was characterized by two things that I found quite remarkable. One of them was customers weren't really aware on how to consume our communication. I know Brian's touched on that. The other piece that was interesting is that customers that had one ExpressRoute circuit may or may not have experienced an impact depending on where they were peering or going through the same peering location. This created a little bit of confusions for customers. Multiple circuits were fine, but single ExpressRoute circuits may or may not have experienced impact. We've got Shruti over here from our ExpressRoute team to talk to us about ExpressRoute resiliency and how to best leverage that.
Thank you, Sami. Hey guys, my name is Shruti and I'm part of the Global Black Belt Azure networking team here in Microsoft. Today, what I have on my agenda is to quickly cover ExpressRoute, starting with what is ExpressRoute, what are the resiliency options that we provide with ExpressRoute, and our new guided portal overview on the on Azure portal to see how it works, what it brings. Along with, as time permits, we'll quickly touch on some monitoring options. So with that, let's move to the next slide and talk about what is ExpressRoute. ExpressRoute is a dedicated connection that provides connectivity from your on-prem resources, which could be hosted on a data center, branch location, however you set up the connection, all the way to Azure. Now, what does Azure mean, right? So it could be to your private resources that are hosted in a virtual network, including any private endpoints that you have using private peering over ExpressRoute. You could also connect to your PaaS resources, which are hosted over publicly routable IPs, but you do not want to connect to them over public internet. You want that dedicated connection to those resources. You can use Microsoft peering within ExpressRoute to get that connection. Additionally, you could also use Microsoft peering to connect to Office 365 resources, be it Teams, Office itself. But keep in mind, Microsoft always recommends to use Office resources over internet because that's where it is optimal. But of course, if you had some compliance or security reasons that you need to do that, please go ahead. There's a whole approval process for it. Fill in the forms, and as and when it gets approved, you can go ahead and use that. Now, we've discussed quickly, we've touched a little bit on all of this, what circuit is, what it does. Let's talk about the resiliency. So what happens when you get this circuit? So I'm going to bring up my whiteboard so I can quickly touch on that piece. So here, what I'm sharing right now is what you get when you buy a single ExpressRoute or you opt for a single ExpressRoute. We call this our standard resiliency. So what happens is when you go order an ExpressRoute, Microsoft has been catering, enterprise connectivity for a long time. So we always make sure that you get a redundant link. What that means is you will always have two physical links which are connected to two physical Microsoft Edge routers, right? Extending all the way back to a customer edge or a partner edge. Now, why do we say customer edge or a partner edge? And just to add a few seconds on that. So we have two kinds of ExpressRoute connections. One is provider circuits and one is direct. So provider circuit, as the name suggests, there is a partner edge in the middle or the provider in the middle who will extend the connectivity all the way to a customer edge. Right? If you already have built-in relationships with the partners, depending on where customer routers are, where customers have their presence, what their POP location is, that might be an optimal option. But there are also scenarios, be it higher requirement of bandwidth or customers' POP presence in the same POP as Microsoft. They could also use what is called as ExpressRoute Direct. direct. So direct terminates directly to customer edge routers. So there are 3 nuances to that, but from a hardware perspective or the redundancy perspective, what I'm talking, you will notice it's pretty much the same. So we are just going to talk in general, and I will just call out a few differences as we move forward. Okay, so going back to what we were talking about, so yes, you have 2 physical links from Microsoft extending towards customer or partner edge, which means you are completely covered in case of a hardware failure or a maintenance that Microsoft is performing in one of its routers. You are totally covered with all of that. But one thing to remember is both these routers are in the same peering location. So if you guys are aware of the infamous Equinix peering location outage that happened in Chicago, this is what happened. The entire peering location was not available. So we had, of course, Microsoft Azure customers were also impacted because you might be covered from a hardware perspective, but you're not covered from a region perspective, so or peering location perspective. So if it's down, you're completely down. So what are the things that you could have done to avoid being in that kind of a situation? First, depending on your disaster recovery requirements, you could simply have your primary traffic all run over ExpressRoute, but you could have your secondary, this is specific to private peering, guys, for private resources, you could have a secondary link connecting all the way to on-prem using a VPN. So meaning ExpressRoute is primary, when your ExpressRoute is down, you are covered via VPN. But things to remember, VPN is over internet, encrypted over internet, which might be fine for a few customers, but let's say you have critical workloads, you still have that dedicated bandwidth requirement, even at the time of an outage, then this might not be an optimal solution for you. Then what you might need is our maximum resiliency. So let's shift our focus towards maximum resiliency or dual ExpressRoute. So what is maximum resiliency? Here, what you do is you get 2 different circuits. So you have 4 links, right? For each circuit has 2 links. You have 4 links, and you make sure when you get these circuits, you pick different peering location. And of course, it extends to customer edge or the partner edge as marked here. Now, here you are covered from a hardware perspective. You are also covered from a peering location perspective. So in case the hardware is down, you have a link. In case your peering location is down, you have a backup path. This is an excellent option, and this is what Microsoft will always recommend. But we also understand that this could be cost prohibitive. We've had requests from multiple customers saying, okay, this is great, but what we have to pay for an additional whole new circuit, which is probably not feasible for certain customers, right? At least at the stage that they are in. So they look for different options, which provides them where they don't need to use site-to-site, but at the same time provides them resiliency towards these peering location failures. We heard all that feedback and we said, okay, so we are going to come up with something new, still preview, available only in select locations to test. But what we did come up with is high resiliency or our Metro ExpressRoute. So what is this? Let's take a quick peek. So what this does is, this is still a single ExpressRoute circuit, but with a catch that your 2 MSCs or Microsoft Edge routers are in different peering location, meaning in this example, as you can see, it's in Amsterdam, where your Microsoft Edge 1 extends the connectivity to customer edge. And your second location is Amsterdam 2. So your Microsoft Edge location, Edge router connects, the second link is via Amsterdam 2. So here again, similar cost as a single circuit. You cover hardware failure, you cover peering failure. This might be a good option for a lot of customers who want to get this resiliency, but at the same time want to be mindful of cost. With that said, with all these options, you must have realized that this is still preview. We are working on advancing it to multiple locations. If you're interested, please reach out to us and we can see how and when what can be available for you guys to test. Okay. Since we've spoken about all the different resiliency options, what I want to quickly touch on is another factor. So one question that comes up very often is, between direct and a normal provider circuit, what is the difference? I spoke about, you terminate directly to customer edge, partner edge. But the difference is when you go a provider model, this port is not dedicated to a customer, meaning you could have multiple customers terminating via their provider to the same port. How does Microsoft differentiate between these different customer traffic on layer 2? What we do is we use an encapsulation called Q in Q, which is nothing but .1Q inside .1Q. So there is a VLAN ID, which the partner and Microsoft together add. Yes, we decide on a common VLAN ID. We say, okay, this is what it is. Let me just pick 100. Let's say 100. So that has to match on the partner edge on the customer edge. Partner edge and on Microsoft edge. But at the same time, every time you create a new circuit, there is an outer tag or a VLAN ID that's unique to each circuit that we call S tag. So every circuit has its own VLAN ID or S tag. Additionally, the VLAN ID that you guys add, that's C tag. So that's how Microsoft differentiates each customer traffic versus direct, where the entire port is dedicated to the customer. You will not have any other customer using that port because you purchase the entire port pair, not the circuit, right? You can build additional circuits on top of it, but you have the entire port dedicated to you. So now here you have an option. Do you want to do Q and Q? You can. You want to do .1Q? You can. Whatever kind of encapsulation you want to do. A few things, just something to keep in mind when you pick what circuit you want to use and from a config perspective to be aware. Now I want to touch on Azure Guided Portal Preview. This is a new feature that we've introduced for our customers. One thing to keep in mind, what you see on screen, this is a preview portal. So if you go to your portal and try to just type ExpressRoute, you might not see this. So just use the preview links that we will share in the links later. When you go here, you just click on ExpressRoute and it'll take you to this view that I have. This makes it easier for you to set up maximum resiliency, standard resiliency, whatever you want, right? This just makes your life a little bit easier. Now let's just pick a resource group. I already have a ER resource group that I had created. It shows a small snippet of based on the resiliency that I choose. So I chose maximum resiliency here. If I had chosen standard, it will show exactly the images that I showed you a while back on the whiteboard. So this kind of highlights or tells you what you're getting into, what you're picking. Now, when you try to create your circuits, you have an option to create a new one in location 1 or use existing. I want to use an existing circuit that I already have for my location 1. Now, location 2, I go ahead and create another circuit. Now, the good thing about this is when you go choose a peering location, my primary circuit was in Dallas. So if you look at this, it gives me a summary or miles that in kilometers, miles, both the distance from my primary peering location. So this helps you make an informed decision of what is the second peering location you want to pick, right? So for example, I pick San Antonio. I pick, of course, let's make this South Central US, and port type is provider. Of course, for my demo, at least I've used provider, and Megaport is my provider for this test, and I'm just going to name it as demo ER3. Again, SKU, standard or premium. Standard is you can connect to virtual networks in the same geopolitical region. So for example, since I'm creating in Dallas, so anything in North America, I can connect to that. If premium, there is no limit on the geo region. I can connect to anywhere in any continent, anywhere in the world. Metered and unlimited is just a billing model. So metered means you will pay for this circuit. You will also pay for the egress cost. Unlimited, you will pay upfront. I always recommend customers, unless they already know, to start with unlimited to see how your usage is. If you're going big, and if it really gets to a certain more, if you're utilizing more than 60% of the circuit, unlimited might be a good option for you. It's easy to move from meter to unlimited. Okay, that's a quick rundown, and then I go ahead, do a create. What I'll get once I'm done is a circuit like this. A circuit that is in the peering location that I picked. It is not provisioned. I have to put in, of course, provide the provider with the service key, get it provisioned, then do my private peering config. I also have my circuit where I have that config. So let's touch what that would look like. So here's my circuit, which was in Dallas. It's all provisioned. I have my private peering config all done. Let's just go to the config for a quick minute. Most of the things here are self-explanatory. You know, peer ASN 2/30s that you need to create the circuit, and then is your VLAN ID. VLAN ID is where is the C tag that I was talking about. This is where you pick, you know, between the partner edge and the customer edge and the Microsoft edge. This VLAN ID has to match. Now let's quickly take a look at the monitoring options. What you can do is once you create, you have the private peering. You should see the ARP records of on-prem. You should see the BGP up once it's all set up. So once I click on this ARP records, this is the view that I'll get. You will typically see both on-prem and Microsoft Macs here. Depending on what router you'd end up on, you might see that Microsoft ARP is not there. That's a possibility, for something for you to be aware. You can also check what your BGP status is. Is it up, down? For how long has it been up? So this is great when we are talking about you know, monitoring at the time of the issue or when you're creating it. But if you wanted to do monitoring later, go back in time, pick metrics. You know, here you can go back in time. You can check your ARPs, BGP, bits in, out, which is particularly useful as from a pricing perspective because we charge you for egress. We also have connection monitor, which does end-to-end monitoring, but I don't have time to touch on that. But just something to keep in mind, if you want to do end-to-end monitoring, you can use connection monitor. I hope this has been informative for you, all of you. With that, I'm going to hand it over back to our host. Thank you, guys.
Thanks so much, Ruthie, for covering Azure ExpressRoute and our resiliency options and going through the demo. So now we understand that you likely have and leverage multiple Azure services to deploy your workloads. So we've built the Azure Proactive Resiliency Library, April for short. And it's a one-stop shop for resiliency guidance and automation to check your resiliency confirmation against your workloads. Another item I really wanted to quickly talk about to help you start and deploy Resilient is called Azure Verified Modules. Like April, Azure Verified Modules is a one-stop shop for infrastructure as code automation with both Bicep and Terraform Azure resources. Just a quick plug for our August session. We'll likely cover these last two tooling capabilities in more detail. Sammy, do you want to close us out?
No, super. Thank you very much. And thank you to all our guests and our customers for joining us. We have a lot of information that we went through. I am pleased that this is going to be recorded and published so that customers can view this. For us, in a world that's driven by automation, being human is super important. And so bringing the humans behind Azure to our customers and kind of meeting us is really important. One of the things that we really would like to do for our next session is hear from you. What do customers want to hear about? What are the things that are important to do? We've sprinkled some ideas or suggestions because they're easy ones to grab SMEs from. But if there are topics that are important to customers where they can kind of build their confidence in the cloud, then please let us know and we can make sure that we tailor these sessions for you. But thank you very much for joining us. Thank you, team. Thank you, Kelly.
Thank you, everyone.